So the directions say calculate flux, right? So f of x, y, z is equal to the vector field with components z, x, and 1. So the z component is actually 1, right? S is the part of the paraboloid z equals 9 minus x squared minus y squared that lies above the square. X goes from 0 to 1 and y goes from 0 to 1. That's actually good news there. And has upward orientation. Okay, so let's draw a little picture of this, or at least part of a picture. So z equals 9 minus x squared minus y squared. What does that look like? Oh, well, yeah, I mean, it's an elliptic parabola, yeah. And how do I know it looks like that? Yeah, you could think of it as 9, z equals 9 minus the quantity x squared plus y squared, right? So negative x squared plus y squared points down, and then the plus 9 moves it up 9 units, right? So that this vertex right here is 0, 0, 9. And we're actually going to integrate, and I'm not going to try to draw this, but we're going to integrate. This is going to be our region. I could draw it separately. That's going to be our region in the xy plane, right? So we'll worry about that in a minute if we need to draw it. I don't know if we will. But the flux, we know, is given by this integral. Surface integral f dot n ds. And this tells us what to do. Well, I kind of like to write the calculation formula. We're actually going to project down into the xy plane and onto r. Well, we don't really need to do that because we're kind of given r. But what's the calculation formula? F dot, yeah, well, plus or minus technically, right? It's going to be one or the other, right? And we just make sure that it has upward orientation, right? Which means positive z component. And then dA on the end. So this is the formula that will get us where we want to go, right? What does it tell us to find? Even before del g, we need to have g. Okay, what function's related to g? This guy. But to make it g of x, y, z, we set it equal to 0, right? And if you want to think of it in terms of this formula, you keep the z you keep z positive, or you make z positive if it's not already, right? And bring the other stuff to the other side. So z would be, so we would have z plus x squared plus y squared minus 9 equals 0, right? And then we just lop off the equal. So that's what you get if you solve this equation or move everything to one side. And get 0 on the other side, and we just lop that off, and we lop off the equals 0, and that's what we call g of x, y, z. And so when you set it equal to 0, that's actually a level surface of g of x, y, z, and we know that if you take del g, then that's going to be a vector that's normal to that level surface. So that's we're trying to find a normal vector, right? So that's why all this works. So then what's the next thing to find? Del g, and I'll do component form here. What's that going to be? 2x, 2y, and 1. So one thing I should point out with this example is because we have a constant k component, you don't have to worry about getting it in terms of x and y, right? But if that thing that I circled were in terms of z, you would have to plug in the value of z in terms of x and y, which is given to you right here. And that will occur in some other later problems, right? So be aware of that. Because we're creating a double integral, right? You can only have 2 inputs in your double integral. You can't have an x, y, and a z. But it's just good to think about for later on. And then the positive one will work, right? We don't really need the negative one here, the negative del g. Because we're looking, okay, so it says upward orientation, right? Well, then that's going to be the outward pointing vector, isn't it? Because you can see the outward pointing vector is going to have a positive third component, right? Whereas if you took one that pointed inward, it would be going not straight down, but it would have a negative k component. So this is the correct del G to use. But if you needed the other one, just take the opposite of it, right? Okay. So then what do we do with that? With F, you know, it's not, I know you guys don't like to write this much, but it's sure not a bad idea to write the components right next to each other. So F is Z, X, and 1, right? That way everything's right in front of you, and you're less likely to make a mistake. So then we take the dot product, F dot del G. And what do you get? 2xz, right? Plus 2yx plus 1. And that's your integrand. Would you buy that? So that so then your flux, sometimes I just write it down rather than writing down the formula, but when I say flux equals, I mean that, right? Okay, so filling in this formula then, what's the integrand? It's this guy. So 2xz plus 2yx plus 1. Everybody buy that? Is there any reason not to do a standard dy dx differential order? So we do that. Yeah, there's something else to do. We do that. But let's pretend like we don't know that yet. You're going to figure it out real quick is my point, right? So what are the limits of integration? 0 to 1. Okay, wait. Y goes from this 0 to this 1. Okay, doesn't really matter, does it? X goes from this 0 to this 1. Now, you go to integrate it, and you see, that's when you see the z if you didn't see it already. Oops. Yeah, there's 3 variables here. So what do you do? There you go. All right. So as long as you see it eventually, it doesn't matter. All right, maybe I should do this as scratch work. So 2xz is really what? 9 minus x squared minus y squared? So what does that become? 18x, 2x cubed, minus 2xy squared. Okay, now, so that's what this portion becomes, right? Do we have any like terms? Darn it. Okay, so now we can just put it all in there, right? Does the order really matter? I don't think so. So I'm just going to put all this in. 18x minus 2x cubed minus 2xy squared plus, oh wait, wrong one. That's what we substituted in for, so cross it out. And then plus 2, can I change it to xy? 2yx? Huh? You'll let it slide? Okay. Plus 1, and then dy dx. There we go. Does everybody buy that? So, I mean, this, is it okay if I stop here? It's not necessarily a tough one to evaluate, right? I mean, a lot of terms, but term by term, it's not going to be that bad. What did the answer turn out to be? So make sure you get 29 thirds when you evaluate that, right?